Okay, the next thing we're asked to do is plot these original functions and the composites, f composite g and g composite f. Notice the new notation, f circle g and g circle f, mean composite. So you should be aware of that. All right, so if we go into our calculators, we've already got in y equals f and g and f of g. I'm going to go down to y4 and put in the notation for g of f of x. You might want to think about that, pause, and try that yourself before you see how I do it. Here we go. Did? I hope so. Alright, so if we go to our graphing screen, we'll see all four functions being plotted. Now, if we wanted to look at just one at a time, we go back to our y equals screen, and if we move the cursor over the equal sign, we can toggle any particular equation on or off by hitting enter. So I'm going to go down and toggle off the two composite functions and g. So now if I go back to my graph, the only graph that's turned on is f. And you should see that. You can see the window that I've set as well. So then we can go back and look at G. Toggle off F and toggle on G. Graph. There's our graph of x minus 3 between 2 and 7. All right. And then a graph for f composite g. Of g. Notice here. And if we do the same for g of f, we should get this graph. And there's our equations for each of those. Okay, now that we've produced the graphs, we want to see what the equations look like. So the next thing we're going to be asked to do is find an equation that expresses f of g of x explicitly in terms of x. And then find the domain and range of the composite function algebraically. And then we'll check it out and make sure it agrees with the graph. All right, so the equation, we follow the process. We plug g of x, x minus 3, into f of x. So we take f composite g, we take negative 2, and the x in f we replace with the information from g. So x minus 3 replaces the original x plus 8. Now, from here, we simplify. So, negative 2x plus 6 plus 8. We distribute the negative, which becomes negative 2x plus 14. So there is our equation, explicit equation for f of g of x, negative 2x plus 14. Now, to find the domain is a little bit trickier. What we have to think about is the process that either worked or broke down in our earlier question. First thing we do is we say that for our domain, we can't get started unless it's true that x is between 2 and 7, because g, we need to plug a value into g as our first step. So first, that has to be true. Now, the second place where it was possible to break down was the answer we got from evaluating g of x that we tried to plug in to f of x. So our answer from g of x, or our calculation from g of x, had to meet the domain restrictions of f of x. So what I'm going to do is I'm going to take that process of getting our answer and I'm going to make sure that it falls between 1 and 5. So I start with 1 less than or equal to our answer of g of x, which has to be between 1 and 5, or I can't get through that second step. Now I solve this compound inequality for x. So I need to get that -3 out. So I'm going to add 3 everywhere. This is a democracy, equal treatment to one and all. So now I have 4 is less than or equal to x is less than or equal to 8. So this condition also has to be true, or I can't get to the end of my process. So I know that this first expression, 2 is less than or equal than x, and is also less than or equal to 7, has to be true, and the second expression has to be true. 4 is less than or equal to x is less than or equal to 8. If I'm evaluating these two situations, they both have to be true at the same time. So I draw a number line with these two possibilities. Here's 2, here's 7. So step 1, x has to be somewhere between 2 and 7. For step 2, x has to be somewhere between 4 and 8. And the only way I can get to a final answer is if both of these conditions are true. So I look on my number line to see where both conditions are true. And that comes in between 4 and 7. So only if I start with numbers between 4 and 7 will I be able to get an answer. All right. Now, to find the range, I need to go and look at my graph and figure out what the highest and lowest y values are. Where do they occur? So I'm going to go back. Here is f composite g, and the high value is at the left end of the range, so when x equals 4. And you can see that the low value occurs when x equals 7. If I go back to my explicit equation for f composite g, -2x plus 14, I can plug in 4 and I can plug in 7 to find my high and low x values. So 4 gives me -8 plus 14, so 6. And then 7 gives me -14 plus 14, 0. So in that case, my values go for y between 0 and 6. And it matches our graph. Let's try that same process for g composite f. And remember, we start with the inside function. So I'm looking for g of f of x, the domain. So the first thing that has to happen is that I have to be able to plug a number into f. So x must be between 1 and 5, where I can't get started. Now the second step is that my answer from f has to be between 2 and 7, the domain restrictions on g. So for the second step, I take the domain restriction for g, 2 is less than or equal to, and then I place my calculation for f, the equation for f, in for x. -2x plus 8 less than or equal to 7. And I solve for x, being democratic. So I subtract 8. I get -6 less than or equal to -2x, which is less than or equal to -1. Then I divide by -2. Remembering that when I divide by a negative, I switch the order of the signs. So or the direction of the inequalities. So I get 3 greater than or equal to x and greater than or equal to 1 half. Now, to match expectations when we use a compound inequality, we usually use the less than or equal to. So I'm going to reverse the order here. 1 half less than or equal to x and less than or equal to 3, so that I can visualize the compound inequality on the number line. So, our domain, 1 half less than or equal to x less than or equal to 3. So let's recap the steps that we need to solve a compound inequality with restricted domains for the new restricted domain. So let's recap what we need to do to find the new domain restrictions for a composite function. We start by replacing the x in the domain restrictions of the outside function, f of x, with the actual equation from g of x. Once we've done that, we isolate the x in that new expression by being democratic. Now we'll have a new domain restriction. Now that domain restriction must be combined or find the intersection between that new domain restriction and the domain restriction of our inside function. Let's not forget that third step, finding the intersection or the overlap between the two domain restrictions. Once we've done that, our mission is accomplished.